we're going to start now. Screw it.
Hold on.
Okay, my name is Dan Fleury. I have my own company, ABR Services. We came into business in 1986. I've been dealing with VMS since version 1, started in early 79 with a 780, concentrating primarily on internals and performance ever since in various and sundry jobs, working either for myself or for others. And wanted to try to give a performance, a test case going from real machines to the emulated environment and just performance for Alpha in general. And this will carry on to, I think, the new platform as well, both Titanium, that I've done some work on, and the x86, which I'm going to be heavily involved in probably soon. And this is a case study that goes right from the actual hardware to emulation. And at some point, potentially, this will go to x86 as well. So things to keep in mind and some of the trials and tribulations of moving along the way and the problems you can encounter and how to address them. My colleague here, Andrea from Softtech, is the resident system admin at the site for which this case study covers. Initially, this setup was a 4-node ES45 Alpha cluster. Each machine had 8 gigabytes of memory and external SAN storage. I don't recall exactly what that was specifically, with multiple NICs on the Alpha boxes so that we could isolate the cluster traffic from interactive user traffic. Again, just to give a secondary pathway to try to keep things as efficient as possible. Software environment there is VSI's VMS 8.4-2L2. Just to give you an idea, there are approximately 800 interactive users concentrated on 3 nodes of the 4-node cluster. 1 node is for batch-oriented stuff. It is transaction-based. Over 300 RMS data files connected most of the time for each user. A couple of RDB databases, not all of them are active with each user at all times. Batch processes are used for both reporting, like quarter end, year end, that kind of stuff, daily reporting and summaries, as well as generating and sending files via SFTP to external applications. And again, bulk processing during the day of invoices and that kind of thing. Hardware starting to fail. Parts are hard to get. Commonplace for Alphas these days. There are service companies out there that provide hardware service. They are less than stellar based on my experience with customers coming to me. Yes, they'll charge you a lot of money for hardware support. Then when something breaks, they have no idea how to fix it because they barely know what an Alpha is. And it's a long time to get things repaired, typically anywhere from 1 day to 1 week, just because they don't stock the parts. They have to source them from somewhere.
I'm going to interrupt and say that there was the hardware plan to move off of the Alphas to the Titaniums, and change in management pointed the customer in a different direction, which is why they decided to move to an emulated environment. The plan was to move to Titanium, and it got, literally the PO had already been cut when management changed the direction for emulation. And it makes good sense in the sense that, where are you getting the parts from? Why are we moving to hardware that's no longer produced? And so they decided to go with emulation.
And which reminds me, for full disclosure, I am under contract with Stromas, which is the actual emulator provider for this particular client. So I may know a little bit more about the underlying emulator than many. But with the hardware starting to fail, moving to the emulated environment, we wanted to keep everything basically the same. So there's a 4-node cluster for production, and there's a single node DS20 that's used for development. They chose the shared AXP emulator based on a host of 3.2 gigahertz, which was less than recommended for the particular performance level that they were requesting. But that's what they had. 256 gigs of main memory on each of the server boxes, multiple NICs set up in an active passive mode. Cluster storage was provided using a product called put out by Nutanix, and it sets up volume groups, which are accessible to the VMS system. And AXP presented to the existing system fiber channel controllers so that from the user's perspective, the hardware was the same. Oh, thank you. One thing I will note is that, actually, it's on the next slide. I want to get ahead of myself. Oh, thanks. Now the thing is working.
All I did was minimize the chat.
Yeah, okay. All right, you want to see if you can get to the next slide now? Oh, wizard. Oh, there we go. Magic. I'm impressed. So the initial move to emulation, nothing changed. So other than the fact that you are now running on an emulator, from the user's perspective, nothing changed. VMS was still VMS. The connection mechanism was still the same. Changes, I think, were made to the IP addressing, but that was kind of behind the scenes from the user's perspective. The biggest change was that the emulator allowed you to go up to 32 gigabytes of main memory, whereas the ES45s were limited to 8 physically. That could go into the box. So that was done initially. However, when you moved the emulator environment, no changes specifically done to either any of the sysgen parameters or any UAF parameters. So when I first got involved, effectively 45% of main memory was sitting there doing absolutely nothing. Granted, it did it very well, but it wasn't particularly useful for the end users. So we made some changes to utilize the memory that was there, and we'll get into more details of that. Multiple NICs were presented to the Alpha box again to set it up so you have multiple pathways for cluster traffic and as well as interactive use. The disk drives from the VMS perspective were unchanged, had the same names, same designations, except for some sizing. Some of the drives were made larger because of production needs. But again, as far as naming goes, any changes from the VMS environment, nothing appeared to have changed. Batch processing was slower than they expected initially, and SES traffic appeared to be slow. But that was primarily because the setup was a little bit different, and the SES traffic was not isolated the way they originally expected. What we found, hyperthreading was enabled because of the requirement for mechanics, and the way the emulator works, each of the emulated CPUs will consume an entire core to itself, which means if you have hyperthreading turned on, that it is possible for two emulated alpha CPUs to end up on the same core. And hyperthreading is kind of people think that you get two CPUs out of one. You really don't. It's what appears to be two CPUs is really one with some tweaks around to make use of idle cycles. So you're getting the most bang for your buck out of the actual core. Well, you're not going to get 200% of a CPU out of a single CPU. You get a lot less. So we found that performance was abysmal, and that was one of the major reasons why. The emulator allows you to assign CPU affinity, which means we were able to say, okay, I'm going to use core 0 and core 2, and just completely avoid core 1, because core 1 would be hyper-threaded core, or the physical core 0. Get very convoluted talking about it. So by doing that, we were able to make sure that each alpha emulated CPU was on its own core, and that significantly changed performance. I don't have any specific numbers to that. I don't know if you recall any, Andrea, but.
Well, the biggest difference was you could see from the top command, you could see 99% of the CPU was assigned to the Sharon instance. Before we made that change, the CPU might have been sharing with the Linux. The Linux will send the hardware interrupts and be doing Linux work on the other CPU. So assigning them, spacing them out sort of ensured that they only were used on a single core, as he said. And then we had to do another layer, which he mentions here, the Linux layer, and tell Linux not to use the available hyper-threaded core. So that was the other change we made.
That's a quirk of emulator. And I believe the all of the emulators work the same way. And it's primarily because even if an alpha is quote unquote idle, it is still effectively doing a 10 go to 10, which is executing instructions that are doing nothing useful for its equivalent. There are mechanisms available in an idle facility that's available to turn it off. However, that will save CPU time, especially if you're paying for it. The problem is there's a response time penalty to that for it to basically re-engage. In a case like this, where the systems are extremely heavily used to the tune of close to 90% CPU utilization across the board, that's not reasonable. Working sets were set relatively small, and again, given hundreds and hundreds of accounts, going through and updating every account seemed to be more of a pain than it's worth. So what we did is we changed the minimum PQL parameters in SysGen and said, okay, the minimum PQL extent is now 300 or 400,000, made it huge. Larger than it had to be, larger than they would ever get to, but the intent was let VMS manage memory. That's what it's there for, and hopefully it'll do a good job. And to be honest with you, it's doing pretty decent. I noticed in looking at some T4 data that the modified page list fault rate is somewhere between 16 and 20,000 faults per second, which seemed a little high. So we increased the modified page list a wee bit and brought that down to less than 400. So, and again, it's changing the way memory was allocated, but it allowed you to eliminate the overhead of having to handle all these moving of pages from endless out. Now, granted, it's a relatively inexpensive operation, but even inexpensive operations, when executed enough times, become expensive. Pre-list was rather large as well, and we brought the free goal down to minimize the amount of excess memory we had around, again, to try to utilize what we had. Non-page pool kept being increased as I/O activity and other non-page pool requirements became apparent. We, again, would increase it as feedback indicated that it was being allocated. Just again, the initial allocation is going to be better than trying to add to it all the time. Over time, you just grow the initial page just to make things a little bit more efficient. Thanks to Hyman, so this helped, we were able to tune a lot of the RMS files, talking about buckets and bucket sizes, all kinds of other happy stuff that is beyond the case of detail here.
Well, but it's important in the sense that there are over 300 index files in this particular application. And with 850 users all banging on the same files, the locking in this environment is tremendous. And time spent, I don't know, months helping us figure out, okay, what are our hot files? What do we need to optimize? How do we optimize? And I'm sad that it's a one-liner because it would have filled this session. But yeah, we did a lot of tuning of the RMS files to make it that pain that wasn't visible when they were on physical servers. Pain that was not because, for whatever reason, the ES45s managed it. But once we were here, it became obvious. Oh, well, why are we doing this? We can free up some resources.
One of the issues that's behind this whole mess too is performance is a relative thing. And I've been involved with this particular client for over 3 years now, and I've been banging on it, trying to give me something I can use to measure this, because there is no transaction rate. There is no transaction. There's nothing that we can use as a stick in the ground and say, we're doing X amount of work today, and we make all these changes. We're doing X plus Y tomorrow. It's always been, well, it's running poorly today. Well, what does that mean exactly? And that's been a problem for 3 years. It's going to be a problem because the site refuses to define what is production. My gut feel, based on the T4 data and IO data and everything else that's going on in the spots, their own discussion of increased clientele and work suggests we're probably doing anywhere from 30 to 40% more work today than they did on the actual hardware. Yet they're saying the performance is less than it was then, so therefore there's a problem. So if you're doing more work, it's going there is some cost to that. But because we can't define what that more work is, it's that nebulous, it's running poorly stuff. And it's an argument that I've had for the last 45 years doing this. I'm sure it's going to be the next 10 or 15 when I continue to do this like an idiot. But yes, along with the tuning of the files includes managing the number of global buffers per files, it's measuring the bucket sizes and optimizing that, optimizing the file caches to coincide with the bucket sizes to make sure that those are kind of cooperating so that all levels of caching and buffering kind of works together instead of fighting each other. There were some database changes that were handled and covered by SCI. Who handles all the databases for this particular time. Oh, look at that. I should have gone to the next one and summarized everything I just. More frequent converts too, because there's a lot of data that is what I'll call transient. So you get a lot of records that are deleted, which of course leaves a lot of trash around, and more converts, you have to clean that up, makes everything much more efficient. And you're doing some daily, if I recall correctly, right?
No, we can't.
Can't?
No.
Okay.
No.
So it's weekly at least.
Weekly.
And other ones are monthly. Some files were found not having been converted since what, 96?
I think it was 2010, but
There were
yeah.
a couple of them that hadn't been converted forever. Now, again, granted, they're low usage files, so they weren't significant performance hits, but they were performance hits. And as I said, every little performance hit is going to add up over time. We were finding a case where we were running into problems with exec mode being flat out more than 100% of the CPU. And there are known issues with RDB and RMS not playing nice in terms of exec mode usage. And one of the things that was done was to use what's called the remote model. So your access to the database becomes 0::: database location. Which generates an extra process, which means more process context switching, but avoids the exec mode hiccups that were creating a problem. So you get more overhead in one regard, but a lot less in another, and it turned out to be a performance win in this particular case. More work needs to be done in that area. Try to address it by perhaps putting all RDB access on a singular node to cut down on blocking and some other issues behind the scenes, but that's under investigation and experiment now. Go ahead.
And in order to do that, we would have to have a stable cluster. Because if the node that's running RDB shuts down and we have to flip it to another node, the users are going to feel that pain. So in order to, which is why we left it, it's a local remote connection. So if that node goes down, then only those users are impacted. But ultimately, the best solution is to avoid the cluster lock with traffic for RDB and put it on one node, but we're not there yet.
You had the RDB licensing challenges, right? The prices.
Well, no. If we take the same 20, if we take the same 24 licenses and just it doesn't change. No, but yeah, I mean RDB's licensing policy is horrible, so I hope nobody from RDB is here. But they charge you. You need to park your car, and you want to pay for your parking space. They want to charge you for the whole damn building. There are 496 parking spots, but I only need one, so that's the challenge.
So one of the more recent changes was to move from 3. As I may have indicated before, the idea was to have a bunch of interactive nodes on one batch node. So the thought was to reduce the number of locks and reduce some of the SCS traffic. To move from 3 nodes or 4 nodes total to 3 nodes total. 3 interactive nodes to 2 interactive nodes, and that was done relatively recently. So we went from 3 ES45 base boxes at 32 gigs each to 2 GSA systems, 64 gigs each. So we had a net increase of memory availability, a reduction in number of nodes, which in theory should bring down the SES traffic and blocks. And we also, in that process, went from 4 CPU ES45s to 8 CPU GS80s, which if you look at the CPU pool, resource pool, went from 12 CPUs to 16 with interactive users. This has been what's the word I want to use? Challenge.
Yes.
And we run into some other interesting issues, but for the most part, it's been a success. One of the reasons we moved to this model is that one of the three nodes was banging up against the 400% CPU consumption. Unfortunately, at the time, we weren't told those particular users were what I call the speeds and feeds. They're basically data entry, which means they're going to put data in as fast as the system will allow them to put it in. So when we went to the two node model, they went from 4 CPUs available to 8 for the same number of users, and they very quickly consumed all 8 CPUs. Never got any complaints or never got any feedback saying that the performance was better because their speeds and feeds, they're going to go as fast as the system's going to let them, even with certain amounts of pipe ahead. And they subsequently sucked up all 8 CPUs there, which presented some issues for the other interactive node.
It's quite the amount of data entry.
Yeah.
I think honestly, I think their piecework works, so they get paid by the entry. So they're going to go as quick as they can to get paid. That's my guess. I don't know that fact, but that's my feeling. So subsequently, there's been some other growing pains dealing with that. But we're dealing with increasing pool sizes. We're talking about changing the number of concurrent SCS messages that can happen at one time to try to get more things done in parallel. We're trying to eliminate overhead as much as possible. But we did see a reduction in overall block counts. So there has definitely been a benefit here. This is a work in progress. Go ahead.
The other gain is with the 4 CPU ES45s, we could not have a dedicated lock manager. So now that we've gone to the 8 CPU GS80s, we now have a dedicated lock manager who happens to require a dedicated CPU. But in the end, the performance improved.
Yeah, and word of caution, because a lot of people don't realize this. The lock manager will consume an entire CPU in kernel mode. I've seen this at other sites where people get really concerned because now their kernel mode usage is more than 100%, and forget the fact that the lock manager is sucking up an entire CPU. So by definition, it will be over 100%.
And it might have been using well more than CPU across
Yes.
the CPU.
Across
Correct.
the CPUs, absolutely.
So yeah, all of this stuff has to be looked at in context of how the system is utilized. That's unfortunately something that's oftentimes missed. What's interesting is that when I say that in reference to the performance numbers for T4 or anything else, as a medic, it's the same thing when treating people. One of the things they feed into you in the EMS environment is you need to treat the patient, not the numbers. And just, I was kind of getting off topic, but I think it's important to understand the concept. If I go up to a patient that has a heart rate of 110, by definition, that's tachycardia, and there's medication that you can give to address that. But if somebody has the flu and they're feeling nauseous, they feel like they're going to throw up, their heart rate's going to be elevated. So that doesn't mean they're tachycardic. It means that they're not feeling well. So me as a medic, I'm not going to go in and give them medication to bring their heart rate down, because that's not the problem. You need to address the problem and not the symptom, if you will. The same thing here. Just because you have 120% kernel mode doesn't mean you have a problem, because 100% of that is being consumed by the lock manager, and it's supposed to. That's not a bad thing. That's the way it is. And it's important to do that. And that's unfortunately what's lost a lot in dealing with some of the performance data that's presented. You've got to look at the data and understand it in the context of the environment. That's my time.
Yes, please. You need to go back.
One
How
other
do
thing
I?
I didn't actually.
We went past it. How do I get it up there? Why is it going on its own?
Because I'm messing with.
Oh,
So
They have a stick.
be careful. I like that stuff. So one of the things we're heading to is, and I said this almost 3 years ago too, is that part of this is not always at the system level. A lot of times performance analysis and resolution always looks at the system. What can we do to make the system better? What can we do to use the resources better? And that's good. And the reduction, in example, from 4 nodes to 3, the intent there was to reduce the overhead. And anytime you can reduce overhead, that gives you more resources to put toward the actual application. And that's a good thing. All the efforts that we've done, all the RMS work, all the changes of available memory, all that is to make more resources available for the actual user and application to be more efficient. Along that line, every single user has 2 processes right now. And this is a application written in COBOL. If we could move it toward ACMS, then you might have, say, 10 processes to handle the 800 users instead of 1,600. Clearly, that's going to significantly cut down process context switching because now you've got 10 or 20 processes total instead of 800 or 1,600. So there's a gain of resources down. Application changes. Read regardless is interesting because people think read regardless means I'm not locking a record. It's not true. You are locking the record because you read regardless will say, give me the data, whether it's locked or not, but it will still return a status of whether or not that record is locked. So you can make a determination of whether you want to use that data or do something else because you have to have that locked status. I know that, Hein, you brought this up in some of your RMS talks. There's an option to do no query lock, which is I don't care what the lock status is. Don't take a lock out because I don't care. Just give me the data. Well, that eliminates the whole lock completely. So again, less overhead because you're not locking it all now. Just give me the data. So there's some opportunity to do that. Maybe some algorithmic changes because when this application was first written 40 years ago, they never thought they'd have more than 100,000 records. And right now they got multiple millions. So maybe there's a different way to address this data or to look the data up or something.
Segmented feeds.
That might be more efficient. Another one that I spoke briefly about, I think it's the last Bootcamp, and I'll bring it up here, is COBOL has what's called an initialize statement, which will initialize a record to basically all zeros or nulls or spaces. On the alpha, the initialize statement breaks down into a single call for every single record piece of a record. So if you have a record that has 100 components, every single component or piece of that record will get initialized separately. There are cases in this particular application where there are 400 fields, which means 400 calls to either OTS $move or OTS something or other to clear out that record. Eliminating that by either creating a dummy record that you could just say copy or move the initialization record into this, or to read, even to do a read from the file of record 0 that just happens to be all spaces and zeros, would be significantly more efficient because then that would translate to a single character move of the entire record. In this particular, one of the particular programs I actually looked at here, you had basically a menu that would go in to do a particular function. One of the functions at the end of it would initialize the record and then return to the menu. The first thing you did after returning to the menu was initialize the record. So they actually initialized it twice, and that was the one that had the 400 components, and they were wondering why they were CPU bound in some of these cases. There's a classic example. Now, that's not something an application programmer would necessarily see. I found that because I was looking at machine code. So I wouldn't expect a programmer to know that, but that's the kind of thing that you can find out if you look at that level too. And I'm not suggesting everybody do that, but there are some things if you understand how the actual programming language is implemented, can provide some opportunities for problems. Did I miss anything?
No, I think there was just interesting. I think there was some value added from Keith Paris's talk about SCES configurations and traffic and setting up the number of buffers that they shared. We made those changes as recommended from his talk a year ago to implement this environment to again improve performance. So I think one, coming to these events is helpful because you get exposed to people and other situations, and there are few good examples that came out directly from this event that we were able to implement in our production.
You recall what that parameter was? Wonderful.
Yeah, I can see it on the screen. I'm trying to remember the name.
But basically, it defines the number of concurrent
Current buffers.
SDS methods. What's interesting is that it's an offshoot of the actual hardware that's being emulated, because the PE driver will throttle itself down if it runs into certain problems, but it also will default to a certain value based on the hardware um, that it's using.
You didn't get
So the DE 500, for example, the value is set to 32, which is the number of concurrent SDS messages. And in the emulated environment, because we're emulating real hardware, VMS will see a DE 500, even though it's not real. It's whatever the actual hardware is on post. So I'll take the drastic example. Take an emulated VAX. An emulated VAX is not going to know anything more than 100 megabit per interface because it never saw real hardware that knows that any faster.
10 megabits.
10
10
megabit.
megabit.
Sorry, 10 megabit. We've got VAXs that are running on 25 gigahertz or gigabit backbones, and they're getting not 25 gigabit speed, but they're getting much faster than 10 megabit. But all VMS will ever report is 10 megabit, even though you're actually super higher, because we're actually emulating the hardware. So it gets to be interesting. So you have to kind of tell it, say, yeah, you think you're seeing this, but in reality, it's faster. So trust me, do this. That's the other thing that falls into.
Are there any questions? Do you guys have any other examples?
What's the like processor using for the emulation? Is it
For-
Intel or
It's
It's either Intel or AMD.
I think it's AMD.
In this case, I think it's AMD.
And it's a Nutanix 3. Right now, the hardware is a 3.6 gigahertz. I want to say it's 20. No, it's more than that.
24 core.
24 core.
24 physical.
3.6 gigahertz with, I forget, a terabyte of memory. Is that right?
No, 256.
256 gig. So each of the 5 nodes is 3.6 gigahertz, sharing the same storage. And I think the storage is somewhere like, I don't know, 128 terabytes. It's huge.
it's 4 nodes, but you have the same physical box or 4 different boxes?
Each one is sitting on a VM, on a Linux VM, and the Linux VM is sitting on one of the physical host Nutanix servers, but they can share. The Linux VM can share space. I think we fit 2 on any host. We can fit 2 VM instances on any host, so they can get moved. And what's the most remarkable thing to me is in the middle of the day, the Nutanix environment can move the Linux VM, which is running the Sharon instance, to another box. And VMS doesn't care. VMS doesn't blip. Nothing. VMS is oblivious to the event, which is really absolutely remarkable. I didn't think he could do it, and he's proven it time and time again.
So you use data files and you use log lists.
Yes. We have a couple of container files. We have a container file for the dump off system disk. But the rest of the drives are served up by volume groups that contain disks that were partitioned out of that massive amount of storage.
So from VMS, it looks like a raw device, a DGA device.
Well, even for the container file, it looks like that too. But in the configuration definition, it's pointing to, yes, we can point to a .v disk, or we can point to the LUN for the drive in the volume group. We are the only
site in the Eastern Hemisphere, in the Western Hemisphere. Sorry, the Western Hemisphere, that is running this configuration with Nutanix, Linux, and Sharon. So we are a unicorn for sure.
I noted when I tested my application, just for booting, it meant for what, now for 1,000 to before Ryzen processor. When the time was close to 15 minutes, and then all of a sudden it's 30 seconds, and I thought I broke something.
Oh,
It was running
crazy fast, yes.
very fast, and then like you, I found some other issues that my application that I didn't realize how slow the processor was doing that part. It was fast, lightning speed when I coded it, but I had to do a lot of reduction in the application prior to the move. And one of the things I did, and that was back in the 90s, is we were using our RDB and custom portrait program, and we had a lot of activity to the credit bureaus. And we had local search files also. And to optimize RDB, what we did was nighttime process to reduce the index to preload our tables that we use for searching. That made a big difference. I mean, it took a lot of programming time, but once it started working, it was like you use the system for 10 minutes at around 2 in the morning, and then after that, it was going fast.
That's,
It's an application.
yeah.
You got to know our system hardware and how to get around limitations.
unfortunately, probably one of the more common things I've seen over the years is that the typical solution to a performance problem is to throw more hardware at it.
And that is a problem.
Which is fine to a point, but you will get to a point where there's no more hardware to throw at it. And in a lot of respects, this particular application is at that point where the hardware can no longer accommodate the inefficiencies of the application. And it's not a criticism of the application designers. It's to understand that 30 years ago, they couldn't conceive of anything more than 100 or 200,000 records. Now we're at 20 million and more. And the processing mechanism of that magnitude of a change is different. And the example I'll use, just because it's easy to understand, is a bubble sort. And everybody typically knows what a bubble sort is. Bubble sort is great. If you've got 100 items or less, okay, fine. If you start talking 10 or 100,000, you do a bubble sort, you're going to be here for a while. I don't care how fast it should. So you do a different sort mechanism, and you can get it done in a couple of seconds. Same thing here. The mechanisms they use to go through and do their work is fine if you had 100,000 records or less, but when you're at 20 million or more, it's just not efficient because of the volume of records you got to deal with.
Also, the number of users.
Well, the number of
And
users
and
too.
you've changed the balance in the system.
Absolutely.
The CPU, the disk speed ratios have changed.
Well,
Yeah.
what's interesting is
And that's going to
this-
change the
Yeah.
parent performance.
Right. And I keep hearing arguments saying that, well, the NIT can't be the problem because it's a 25 gig backbone. I don't care if it was a 2 million gig backbone. It's the number of operations per unit time is a limiting factor. And it's funny because I go back to further than I want to, but back to the Unibus versus the Mass Bus, if anybody remembers those things. Okay, Unibus is 1.1 megabytes per second transfer rate. Mass Bus was 2.2. But yet, when the RA series devices came out, the RA disks were blowing the doors off of the performance of the Mass Bus devices for two reasons. Number one, the RA devices did out of order I/O completion because it optimized it based on the heads physically moving into the disk. And number two, the transfer rate was never an option or never a factor in the transfer of data because 99% of the time the transfer size was less than three blocks.
Yeah.
And the time difference for transferring 3 blocks of data between 1.1 and 2.2 is almost immeasurable. And the example I used to use is grandma drives a Volkswagen Bug, grandpa drives a Ferrari, they got to go 1 block. Who's going to get there first? They're probably going to be close there at the same time because the time is not driving to the car from point A to point B, getting in the car and starting it, right? which for both is basically the same. Doing the actual drive is a small part of the whole process. So, like I said, you've got to look at the context of things. And I think that's where a lot of these performance issues kind of get stuck and never really get solved. Most people don't look at the whole picture, look at the whole context. But it's fun to do. Must be, I've been doing it for 40 years.
Are you still using the mechanical hard drives or have you done all?
All the drives are now SSDs, and I would have expected better throughput, and I just haven't seen it. And that may be just the way the application's written and how it chooses to access. So the time isn't about how quickly the record came back, but then what do they do with the data, right?
Because I mean, it's not unusual to see anywhere from 5 to 10,000 payloads per second on that system, and it's not even stressing IOS subsystem at all, not even close.
But the other part of that is the only time I see that is when the database activity is doing its backup, or it's when the database work is doing bulk activity. If I've got 800 users, my I/O rate is probably under 700 IOs per second.
Yeah, we've turned the system into a CPU box basically, and the CPUs are not pegged because there are other factors that are preventing it, which is the locking activity is slowing, it's throttling some things down, and the users themselves are throttling things down based on what they're doing. What's interesting is that if you look at the transaction as a whole, as the data input section where the user is involved directly, they hit key to actually do the work they requested it to do. The slowness that gets reported is rarely in the filling out of the form. The response to get the data that they're requesting onto the screen before they actually go and process it is very, very fast. It's the bulk processing where they have to update, I don't know if they do all or some of those 300 files is where it takes the time to actually process. So we've turned it into a IO limited box to almost a CPU limited box with caveats. So throwing more CPUs at it isn't necessarily going to solve the problem because there are what I'll call coordination throttling is what's going on. But it's an interesting problem to have because there's always more work to be done to make it better. But at this stage, the focus now, I believe, has to be more at the application level, be more efficient at getting the work done, finding ways to make that better.
So like one of the things you mentioned is we've gotten the programmers to go back into the code and replace the initialized statements with moving an empty record. They're only doing one initialize in the beginning and holding that record so they can do a move instead of the initialize. So we were hoping to see bigger performance improvements. I know it's changed the profile of the application, but I don't have a measurable number for it. But we know it's doing less work from that perspective.
Raw feeds from tape.
Nope. We are using virtual tapes for the backups. The backups, we're backing up about 7 terabytes data a night, and to virtual tape. No. No, it is. It's about 6.4 terabytes that get backed up to tape, and that process for two batch tape jobs running takes about 2 hours.
Yeah, IO system definitely is not a problem. We run into a couple of issues with odd. How do I phrase this? We had a couple of system hangs, which are odd to say the least, with a lot of processes in RWMPV. The modified page writer is busy, yet the modified page writer is not busy. Still haven't completely sorted that out. Did a sysgen parameter change on the recommendation of DSI to sort of kind of address that, which I still don't entirely understand. But fundamentally, there's because of the volume of what's going on and stuff, it's a unique situation that's kind of potentially exposed a couple of coordination issues, you know, saying that the OS that are still yet to be completely resolved. I think we've successfully avoided problems since it hasn't recurred since we've made that sysgen change, but I don't think it's entirely understood. So they ran into the problem with the x86 version as well, and they had they didn't really call it a fix. I think they called it a workaround to prevent it from happening. That seemed to prevent it from happening, but I don't think anybody really truly understands why.
In one instance, we've done this emulation of old hardware, if you will, that some of the software was written in context that was tightly integrated with the hardware. So you had real-time pulses, real-time clocks, would be the true signal, and I would try to emulate this, and people are missing something on the way.
That has not typically been an issue as far as I've seen. I have run across some cases more recently where more for VAX than Alpha,
Right.
Where things that were working for ever, literally, all of a sudden behaves bizarrely. And of the 4 that I've been involved with, one still hasn't been resolved yet because it involves a third party that's still looking at things. 3 of them were because they found that they were doing things that it happened to be timed just right, so they weren't really coordinated. I hadn't seen one of those in a long time because I know that with early VAXes it was very common because you knew how long an instruction was going to take. So you knew if you did this series of instructions, we really didn't do anything productive for you. It just kind of delayed things enough that this worked. A lot of stuff like that breaks when you go to emulation because emulation works a lot faster. As you indicated, when the alphas worked like really, really fast, we're expecting it. A lot of clients that I worked with that moved from real VAXes to the emulated thought that things weren't working right because it happened too fast. I've done benchmarks like that years ago. Specifically, one that comes to mind because this was the funniest one. It was for the United Nations, and I don't know what they were doing this for, but they had a 4-track program they wanted us to run on a couple of different machines to see how long it took and which one they want to focus on. And it was a very simplistic little program. It did a number of like 100,000 iterations. They wanted to see how long it took. And it was like, boom, done. Wow, that's great. Let's try 10 million. And boom, it was done. I said, what exactly is this program doing? Because I didn't see it. Well, it does this iteration as well. It turns out that the 4-track compiler was really smart. And it found that you were doing these variables and you were doing all this stuff to the variables, but you never used it. So it said, if you're not going to use it, why bother? So it optimized the whole damn loop right out. So you could put that number to be anything you want it to be, and boom, it was going to be done. So it didn't do anything. That was the funniest one I ever did. But by having it, just putting a simple print statement, once it got to the end, it said, oh, I'm going to actually do something with this variable. So it actually did the loop. It took a little longer than that. But yeah, so you got to be careful because sometimes optimizations can kind of obliterate things.
Just since you're here, and having seen this environment, any thoughts?
Sounds like a tag you're in to me.
No, I think there's some value to be added.
I think the scaling of the volume of data is taken into consideration. When back in the early design phase, maybe it was okay to read all the records for one of the customers, but now there's 10 million of them. And you should increase that key with a segment to say, read all the records for this key, for this customer as of this date, or something silly like that.
I would say it's probably time for somebody to do a code review. It's I say this because there was a project that we had a data tree go to a POSIX database, an RDB database, with some files, and somebody programmed it, and 2 days later it was still running, taking 100% of the machine at the time, and a pretty good sized machine.
Yep.
I was called in to take a look at it, and it's just the problem you want solved. They said, yes. It took me about an hour to think about it. It was 5 minutes to code it, and within 35 minutes, the whole job was done.
Yeah.
It's supposed to. But I looked at it differently than, well, because I used to be a hardware engineer, so going to the software, I understood what the computer needed
Right.
and what order things happen, and somebody from a computer science background, oh, this code is elegant. Well, that's not how machine
Elegant.
works.
Elegant is can be a piece of crap.
Yeah, that's part of the point I was trying to make before, is that
Perspectives.
perspective, you have to, it's the individual's perspective. So like the problem I said about we were talking earlier about a looping thing, just loop forever. An application programmer is going to look at an application. What can I put in the application to debug this? As somebody that's focused more on the system, I'm going to have a different viewpoint and a different perspective that I may find something looking at it from the systems level that you're never going to see at the application. That initialized statement is a classic. Nobody at the application level or COBOL level is going to ever even conceive of saying that initialize is going to be a performance issue. It's just zeroing out a record. How bad can that be? And I don't know how I should probably do this on Itanium too and see how it does it on Itanium. I suspect it's similar, but it may do it different on Itanium. It may do it different on x86. I don't know, but it may not be an issue on x86. It may do it a different way. But that's not something that an application partner would ever A, conceive of, or B, take the time to look at. They probably don't want to see machine code anyway. But it's a different perspective, and I think that's where it's important that people look at things from different viewpoints. You always find something.
Sometimes use the word holistic for that, where so many companies are compartmentalized and they're running production and they are running backups and they are running the application, and the application team has stuff to do.
Yeah.
The performance guys don't get in there because they're busy. The application guys. Yeah.
Are you happy with the organization?
No.
305.
No. I'm not happy.
But she's never happy.
But that is a possible opportunity for a future.
Yeah.
But that requires application.
Yes, it does.
Yeah, and unfortunately,
So they have an application department of 5 people.
yeah, and part of the problem is that because they're dealing in their application space, they're constantly dealing with regulatory changes.
Yeah.
So they end up spending all of their time trying to keep up with the regulatory changes, and they don't have a lot of resources and time to address this kind of issue, unfortunately. But again, they can't have it both ways, even though they want it.
Yeah.
And that's part of the problem too.
The ACMS suggestion, I like the ACMS a lot, and it's very effective.
Right.
There can go the official implementation there is ACMS menu going to ACMS Exchange, going to ACMS task. There is also middle ground with the ACMS task interface where, and I'm thinking of, because you suggested they have good response time while they're filling out the form, and then they hit go and it kind of slow down.
Yeah.
So that could be a time to send that package through a task interface.
Yep.
And they will never know it's ACMS at that
Right.
point.
Correct.
A remote subroutine.
Right.
Yep. That might be a solution that's less intrusive than the full ACMS.
So he's done ACMS with lots of, I was there in the beginning with ACMS. My claim to fame is an automated conversion, instead of automated conversion tools written in DCL to convert IBM COBOL CICS to ACMS. And that's not using the database product, but just their ISAM files, their BMS map set. So I was able to write a script to convert the record definitions, put them in the dictionary and create the form, take all the exact CICS code out of the COBOL and run it as an ACMS application. So that's my claim to fame. I've never had to write an ACMS application from scratch, right? I've been able to funnel feed existing code. I wish I could do that for this particular application, but it's written like Lego blocks over the last 40 years. So it's not that organized.
For the ACMS one, I use one silly example of it. If you have one CPU and you have 4 users that need 1 second of CPU time, right? And you're now going to fight over the CPU. So you get a quarter second, you get a quarter second. How long is it going to take before everybody's done? Like 3.5 seconds. Right? So we go 4 seconds to stay. If you put them in an ACMS stack, the first guy gets a 1 second response, the second 2 seconds, the third one 3, and the average is 2 seconds. Boom. So it's just your average rate.
So
because you're not fighting anymore, and somebody is done quickly, and instead of everybody being done late.
And hopefully, who gets done quickly rotates amongst the users, so nobody ever notices that I'm always late.
So this is off topic, but a little tidbit you may want to think, just because. ACMS was originally called Trax 32.
We're not gonna open that.
Trax was the PDP-11, I think it was RSX, transaction processing software, which did not have a very good reputation, which is why they changed the name Trax 32 to ACMS, was one of the reasons. Because the site that I was at in the state of Connecticut, we actually field tested ACMS when it first came out. That was VMS version 4 when it first came out. So
They're
it's
still on ACMS.
They're still looking.
and it still runs extremely efficiently. And it was a decent product. But yeah, tidbit.
Yeah, if this were an ACMS application that we're trying to manage here, we wouldn't need all this hardware.
No.
You know, we would be able to handle twice the users and no more hardware for sure. We would still have plenty of, but trying to get them to an ACMS application requires an application team
Yeah.
that's willing to, you know, work on it, and they just don't have the resources. Oh, guys, thank you so much. Your questions were
and,
great.
Everybody will get this as well, but there's the our contact information. Any performance related stuff, feel free to shoot me an email. I do get hundreds a day, so if you want to put some kind of a something on there that makes it relative to this, something I know not to. My regular email spam folder is so full some day. I get thousands a day sometimes. It's just irritating some days, but no, feel free to contact me at any time. I'm more than willing to help whatever I can.
And if you're annoyed by him, you can just reach out to me.
But no,
I
it's
can play this game too.
my goal at this stage, having done this as long as I have, is I want to try to get as much information out of my experience in dealing with this stuff for 40+ years out to others. Because honestly, your experiences is really where a lot of this comes in, because that's what gives you the context to look at things as a whole, not at one thing specifically. Thanks.
We don't-